All right, guys, welcome to Special Right Triangles Day here. And what we want to get into today is two special triangles that are right triangles. So the first one is a 30, 60, 90 right triangle. And so what you start to do is figure out how to form this triangle. And when you form it, you start with an equilateral triangle, which has 60-degree angles. And then we cut it in half, right? We draw the altitude, the median, right? Angle bisector, all three things at once by drawing this line down. And so we've cut this angle in half, which was 60, but it's now 30. And now we're making a 30, 60, 90 right triangle. And the special thing about this triangle is if we know the measure of this side, right, the hypotenuse, so let's say it's 1, right? That this side, which was 1, we just cut in half. So now this becomes a half. And then we can go about figuring out this side using either Pythagorean Theorem or SOHCAHTOA, and we can figure out if there's, because of this, we can figure out this pattern that develops here. So let's do it. So let's start with what happens if we know the 30-degree angle, right? So if this 30-degree angle is 1, now remember, this comes from an equilateral triangle that we cut in half. So if this is 1, right, that means this whole thing here was originally 2, and that is what the hypotenuse is. So the side across from the 30-degree angle, if that's 1, the hypotenuse across from the 90-degree angle is 2, and we want to figure out what this side is across from the 60. And so if we use Pythagorean Theorem, remember the old c squared minus b squared equals a squared formula, we can plug in. So 2 squared minus 1 squared is equal to a squared. And this is really just 4 minus 1, which is 3. So the square root of this is what this is. And so this is the square root of 3. And you can see this pattern that starts to develop. What if we say that this is 2, right? If this is 2, remember there's another side over here that's 2, so that makes this 4. And then we can do the same thing, right? C squared minus b squared is equal to a squared. We can do 4 squared minus 2 squared. And this is 16 minus 4, which is 12. And then we can take the square root, and here we want to simplify. If we don't simplify the radical, if we don't break this down in the simplest radical form, the pattern doesn't become apparent. When we break down radical 12, it's 2, 2, and a 3. And we end up getting, the 2's coming out, we end up getting 2 radical 3. And so you can see the sides now. If this becomes 2, right, this becomes 4, and this side becomes 2 radical 3. Okay? So what happens if this is 3? So same thing, right? This is 3. There's another part over here for the equilateral triangle. So this is 6. And then just 6 squared minus 3 squared, right? If we use that same formula, we're going to get 36 minus 9, which is 27. Take the square root. That's 3 3's. And then we get this 3 radical 3 as to what A is. Heaters are killing me. Hopefully you guys can still hear me. So, across from the 30-degree angle, we start with that as 3, right? The hypotenuse was 2 times that, that's 6, and this became 3 radical 3. And so this pattern that develops is that whatever I call the side across from the 30-degree angle, if that's x, okay, the 60-degree angle is that number times radical 3, and then the 90-degree angle is whatever the 30 across from the 30 degree, the short leg, right, times 2, and that's 2x. And so you can see this pattern that keeps going on. And so we don't have to use SOHCAHTOA or Pythagorean Theorem now. We can just use this rule, okay? But let's examine another one. What happens if we start with the hypotenuse? What if we know that this side, let's say, is 4, okay? So if this is 4, right, that means that the side across from it is going to be, remember, there's another triangle over here. So let me just draw this out so you guys can remember it's there. So this would be 4, which makes this 2. So if we start with the 4, this becomes 2. And then do you remember what's the pattern? If this is 2, this becomes, right, and you can see it, 4 squared minus 2 squared is equal to a squared. So 16 minus 4 is equal to 8 squared, which is 12. And then we get, remember, 2 radical 3. We did that earlier. And so this is just 2 radical 3. Okay? So the key thing is, can you figure out this leg, right? And then you can use this to get this, the leg with 16. All right? And the way that I always remember this is that if it's a 30, 60, 90, it has a 3 in it, with 30, and that's with a radical 3. So I kind of keep that in mind as we work along for the 45, 45, 90. We'll take a look at next. So once again, what if we change this now? So what if instead I call this, let's do something a little more interesting. What if I call this the 16, right? How does that change everything? So if this is 16, right? Can you think about what this is going to be? Hopefully you said 8, which is right. And then what's this going to be? And hopefully you put down 8 radical 3. And there's our pattern. That's it. Okay? So the rule, now here, I'll fill in a couple more and I'll see if you guys can get it. So what if we put 6 radical 3 here? What if we put 5 radical 3 here? What if we put 7 here? What if we put 9 here? It'll be a little bit trickier. And then what if we put z here? Okay? So it'll be a little bit tougher. So let's see if you guys can do it. Pause it. Try it on your own. And then come back to it. And I'll go through the answers right now. So if you pause it. Oh, don't jump ahead. You better pause it. All right, here we go. So 6 radical 3 means that this side is 6. Remember, if it's x radical 3, that's x. Double it to get the side across from the hypotenuse, that would be 12. All right? Starting with the 5 radical 3. This is 5 radical 3. Remember, this is 5. 2 times that gives you the hypotenuse, that's 10. Okay, the short leg is across from 30 is 7, right? That means that the longer leg is times radical 3, and it's 2 times that for the hypotenuse. If this is 9 hypotenuse, this is half, so this is 4.5, which makes this 4.5 radical 3, all right? And the last one is z. If this is z, this is half, so this is z over 2, and then this is z over 2 times radical 3. Also written as radical 3, z times radical 3 over 2. This just goes like times 1 and floats to the top. So the rule for a 30, 60, 90 right triangle is, right, the side across from the 30 is x, the side across from the 60 is x radical 3, and the side across from the 90 is 2x, okay? And this is given the short leg. All right? So, what happens if you're given the long leg? Right? So that would be if I started with, let's say y is the one in the middle. So I would want to divide y by radical 3, and then I want to multiply that times 2 here, which we can actually write as 2y over radical 3. And what if you're given the hypotenuse? So if we start with the hypotenuse, let's say z, right? Well, we take this and we divide it by 2. And here we multiply the z times radical 3, and that's where we end up with. So those are the 3 different factors. This is pretty easy to remember. So if you can just remember x radical 3, and 2x, you should be good. Apparently we're making popcorn with the radiators back there, so I apologize for the noise we're dealing with right now. All right, giving up the next one. So we're going to stop this right now. I'll start a new one when this comes down a little bit.